The universe operates on a set of rules so fundamental we teach them in introductory physics classes. Causality dictates that cause precedes effect. Ballistics teaches us that when a high-velocity projectile is fired, the signature of its launch, the brilliant muzzle flash, the concussive shockwave, reaches the observer before the projectile itself. This isn't a philosophical point. It's a consequence of physics, of the different speeds at which light and mass travel. You see the flash, then you hear the bang, and finally, if you're tragically in its path, you meet the bullet. Where are you watching from right now? What time is it in your corner of the world? Drop it in the comments below. I read every single one. And make sure you subscribe and hit that notification bell. This sequence is so ingrained in our understanding of mechanics, of warfare, of motion, that it forms a subconscious framework for interpreting events. We are conditioned to recognize this pattern. Energy release first, object second. Now, take that simple, earthbound principle and project it onto the cosmic scale. Apply it not to gunpowder and lead, but to the unimaginable energies and velocities that govern interstellar travel. What happens when you witness a flash of cosmic energy from a specific point in the heavens, and then, precisely on cue, a physical object appears from that same precise direction, moving with a speed that defies local origins? The mind trained in ballistics sees a sequence. The mind trained only in conventional astronomy sees a wild, implausible coincidence. This is the fracture line where our story begins, on a timeline that starts in the summer of 2025 and points, with unnerving precision, towards a pivotal moment in the coming January. We are about to dissect an event that may represent not the death of a star, but the arrival of a visitor, and in doing so, we may be confronting the most significant, the most paradigm-shattering astronomical data in human history. This is the story of a flash, a bullet, and the terrifying, exhilarating possibility that we are not just observers, but the target of an observation. On the first day of July 2025, the automated sky survey systems that tirelessly scan the heavens for movement registered an anomaly. The Pan-STARRS telescope in Hawaii and its counterpart in the Atlas network flagged a faint new point of light. This in itself was not unusual. These systems are designed to catch the transient, the moving, the new. But the initial calculations, refined over hours of frantic observation and cross-referencing, revealed something extraordinary. This object was not orbiting our Sun. Its path was not elliptical, not bound by the gravitational well of our star. It was on a hyperbolic trajectory, an open arc, a one-way ticket through our solar system. Its speed was too great, its angle of approach too steep. It was an interstellar object. The scientific community, still buzzing from the revelations of Oumuamua in 2017 and Borisov in 2019, now had its third confirmed visitor from the depths of the galaxy. It was designated through Atlas. The 3us prefix marked it as the third interstellar object, a badge of profound rarity. For decades, such objects were theoretical. Now, in less than a decade, we had 3. It suggested a galaxy far more populous with wandering debris than we had ever imagined, or perhaps hinted at something else entirely. Atlas was a mystery, but at this moment it was a mystery comfortably filed under natural phenomena. It was a rock, a comet, a piece of planetary flotsam ejected from some distant alien star system millions of years ago, now passing briefly through our neighbourhood. The protocols were followed, orbital parameters calculated, observation time allocated on larger telescopes for spectroscopic analysis, press releases drafted. It was a major discovery, yet one that fit, however excitingly, within an expanding but known category. Then, 24 hours later, the sky erupted. On July the 2nd, a network of orbiting observatories dedicated to monitoring the high-energy universe, NASA's Swift and Fermi gamma-ray telescopes, the European Space Agency's Integral, simultaneously triggered alerts. Something had unleashed a titanic flood of gamma-ray photons, the most energetic form of light in the universe. This was a gamma-ray burst, or GRB. In standard astrophysics, GRBs are the birth cries of black holes, the final catastrophic signatures of stellar collapse or neutron-star mergers. They're events of almost incomprehensible power, compressing more energy into a few seconds than our Sun will emit across its entire multi-billion-year lifespan. They're cosmological beacons, visible across billions of light-years. The official machinery whirred into action. The burst was catalogued as GRB 254, 2b. Its location was triangulated, and as the data poured in, a quiet, unsettling detail emerged in the initial reports before the narrative solidified. The burst appeared to originate from the constellation Sagittarius, the same region of the sky where, just one day prior, humanity had pinned the location of its newest interstellar visitor through Atlas. The immediate institutional response was one of statistical placation. The universe is vast, the reasoning went. Sagittarius is a busy place. It houses the dense star fields leading toward our galaxy's central supermassive black hole. Transient events happen there all the time. To have two rare events occur in the same general direction within a day was just that, a rare coincidence, a fluke. The official classification for GRB 250702b was stamped Natural Gamma Ray Burst, Distant Cosmological Origin, Standard Physics. The two events were decoupled in the scientific literature. 3 Atlas was a local solar system event. GRB 250702b was a background deep space event. They existed in different realms, their proximity a trick of perspective, a simple case of two unrelated phenomena appearing along the same line of sight from our tiny vantage point. This was the clean, safe and professionally prudent explanation. It required no new physics, no challenging of paradigms, no uncomfortable questions, but the data itself began to whisper a different story, a story heard not in the press releases but in the dry technical language of the observational reports. The initial analysis of GRB 250702b contained qualifiers, caveats, notes of strangeness that seasoned astronomers recognize as the fingerprints of an anomaly. The burst was described as having an unusually long duration, not seconds, not minutes, but hours. Its emission profile was labelled structured, implying it wasn't the clean chaotic spike and decay of a simple explosion. There were mentions of extended X-ray precursor activity and an atypical light curve. These are the phrases used when the data stubbornly refuses to fit the pre-labelled box. They are the scientific equivalent of clearing one's throat before delivering bad news. So, the stage was set with two profoundly rare actors. In one corner, through Atlas, only the third object of its kind ever confirmed, a physical piece of another star system now traversing our own. In the other corner, GRB 250702b, a gamma-ray burst of bizarre and prolonged character. They appeared on consecutive days from the same cosmic neighbourhood. Officially, they were strangers passing in the night. But to anyone looking at the sequence not as separate catalogue entries, but as a potential continuum, a pattern emerged. Flash, then bullet. This is where we must abandon, temporarily, the language of astronomy and borrow the clearer, more visceral language of engineering. Consider the ballistic analogy not as a metaphor but as a potential physical model. At relativistic velocities, speeds a significant fraction of the speed of light, the universe behaves in counterintuitive ways. One of the most critical effects is relativistic beaming. An object moving towards you at such speeds will have its emitted radiation, light, radio waves, even gamma rays, focused and amplified into a narrow cone pointing directly ahead, like the headlight of a train. If that object needs to slow down, to decelerate from these insane velocities, it must shed an astronomical amount of kinetic energy. That energy doesn't just vanish, it is converted and radiated away, often as electromagnetic radiation. And due to relativistic beaming, that radiation would be projected forward along the object's line of travel in a brilliant focused beam. To an observer situated directly in the path of that approaching object, you would witness an intense, sustained flash of high-energy radiation, a deceleration signature, before the light from the object's physical structure, which is also travelling at light speed but emitted from a point further back along its trajectory, finally reached you. The temporal gap between the flash of braking and the arrival of the object would be a function of distance, deceleration rate, and the finite speed of light itself. You would see the muzzle flash of the cosmos, then you would see the bullet. Let me state this with unequivocal clarity. I am not claiming this is what happened. I am not presenting this as proven fact. What I am doing, and what the institutional response has pointedly avoided doing, is asking the question aloud, what if the sequence we observed, GRB 250702b, then the confirmed presence of 3I Atlas, is not a coincidence of unrelated events, but a causal sequence? What if the gamma-ray burst was not a stellar death in a distant galaxy, but the localized, focused energy signature of a relativistic object executing a braking maneuver as it entered our stellar neighborhood? What if 3 Atlas is not merely a passive rock, but the object that performed that maneuver? The implications of this question are so vast they threaten to swallow whole disciplines. It touches on propulsion physics we can barely model, on energy budgets that dwarf our understanding, and on the ultimate question of whether we are alone. It is a question that, if true, reclassifies the most energetic explosions in the universe from natural cataclysms to potential technological signatures. It is a question that transforms 3I Atlas from a curious rock into something else entirely. But we cannot jump to conclusions. We must build this case piece by agonizing piece, scrutinizing each element of the coincidence until the sheer weight of interconnected anomalies makes the official fluke explanation seem less plausible than the revolutionary one. This investigation will span 10 parts, a deep dive into the geometry, the timing, the signal structure, the physics, and the institutional psychology surrounding these 2 days in July 2025. We will explore why the same patch of sky claim is a dramatic undersell. We will tear apart the timeline to show the events didn't just happen near each other in time. Their activity windows overlapped in deeply suggestive ways. We will dissect the gamma-ray burst itself and reveal why its 6-hour, structured, pulsing emission looks nothing like a standard stellar collapse. We will follow the post-burst behavior of 3I Atlas and examine the peculiar spectroscopic whispers that hint it might not be inert. We will confront the uncomfortable role of institutional bias and see how the very systems designed to find truth can sometimes act to preserve comfort. And we will look to the near future, to a specific geometric alignment in January, which serves as a perfect test, a prediction point that will either solidify this hypothesis or dismantle it. The journey ahead requires intellectual courage. It requires us to hold 2 contradictory ideas in our minds simultaneously: a steadfast commitment to scientific skepticism and a willingness to follow the data into territories that conventional wisdom has deemed off-limits. You will hear me hedge, reiterate the lack of definitive proof, and acknowledge the very real possibility that this is all an astonishing run of bad statistical luck. That is the responsible path. But you will also see the evidence stacked, layer upon layer, until the architecture of coincidence becomes a labyrinth too complex to be accidental. We begin with the foundation, geometry, because when the official reports say same general region, they are engaging in a form of cosmic misdirection. The truth of the alignment is far more precise and far more compelling, and the fact that no major institution has published a straightforward overlay of these 2 paths is, in itself, one of the most telling pieces of data in this entire puzzle. The official story tells us that the gamma-ray burst and the interstellar object appeared in the same general region of the sky. This phrase is the cornerstone of the dismissal. It conjures an image of astronomical looseness, like 2 unrelated news stories happening in the same large city. It allows for vast distances and separations, preserving the comfortable dichotomy of a local object and distant explosion. But astronomy, at its core, is a science of precision, of exact coordinates, measured arcs, and vectors plotted in 3-dimensional space. When you move beyond the press release language and into the actual data, this comforting vagueness evaporates. The relationship between the path of 3 Atlas and the origin point of GRB 25702b isn't just a loose geographical overlap. It is a vectorial intersection so precise that it transforms the word coincidence from a statistical shrug into a question of geometric improbability. To understand why, we must first understand how astronomers map these 2 very different kinds of phenomena. Tracking an interstellar object like 3I Atlas is an exercise in celestial billiards. The object is not in orbit, it is passing through. Its trajectory is a hyperbola, a smooth, open curve defined by its velocity and the sun's gravity. Astronomers take a series of precise positional measurements over time, astrometry, and from these points they compute the object's velocity vector. This tells them not just where it is in the sky, but where it came from and where it is going in 3-dimensional space. They can trace a line backwards, out of the solar system and into the galactic void to determine its radiant, the specific point on the celestial sphere from which it appears to originate. For 3 Atlas, this radiant was calculated with significant precision. It wasn't just in Sagittarius, It was at a specific set of coordinates, defining a very specific line of sight from our solar system out into the galaxy. This line is not fuzzy. It is a razor-thin vector piercing the cosmic dark. Locating a gamma-ray burst, however, is a messier, probabilistic endeavour. Unlike a slow-moving asteroid, a GRB is a brief, blinding flash. Satellites like Swift and Fermi detect the initial blast of gamma rays, and by comparing the minute differences in arrival times and intensity at different detectors, scientists can triangulate a source direction. This process doesn't yield a single point. It produces an error cone, a pie-slice-shaped volume of space emanating from the satellite, within which the true source is statistically likely to reside. Early detections have wide, fuzzy cones, sometimes several degrees across. As more data streams in from different instruments and at different wavelengths, like the X-ray afterglow, this error cone is refined, narrowed down to a smaller, more confident region of the sky. For GRB25 and Zeus 2b, the initial error cone was large, but over subsequent hours and days, as observatories around the world and in space slew to look, that cone was winnowed down. The final, best-fit localization settled on a region in Sagittarius. This is the general region cited in the reports. Here is where critical analysis must begin. The public is told both happened in Sagittarius. Coincidence. But for the scientists working with the data, the question is, where exactly within Sagittarius? How does the refined error cone of the GRB relate to the hyper-precise incoming vector of 3I Atlas? This is not a question that requires groundbreaking new science to answer. It requires plotting two published datasets on the same map. The data for both exists in publicly accessible astronomical databases. The computational tools to perform this overlay are standard software in any astrophysics department. It is a straightforward, hour-long exercise for a graduate student. And yet, as of this moment, no such overlay has been published in any peer-reviewed journal. No paper has presented a figure showing the trajectory line of 3I Atlas, slicing through the final error ellipse of GRB 25070-2b. The analysis simply hasn't appeared. You can speculate on the reasons for this omission. Perhaps it was deemed too trivial, obviously just a coincidence. Why waste time on a figure? Perhaps it was considered too speculative, venturing into territory that might attract unwanted scrutiny or ridicule. Or perhaps, and this is the more unsettling possibility, the correlation is so tight that publishing it would force a conversation no one is prepared to have. When independent researchers and diligent amateurs have performed this overlay, using the publicly available astrometry for 3I Atlas and the publicly released localization data for the GRB from the gamma-ray coordinates network, they don't find a loose association. They find that the incoming vector of 3I Atlas passes directly through the heart of the GRB's most probable error region. It's not the difference between two events in the same city, it's the difference between two events on the same street. In fact, it's more akin to two events in the same building, at the same address. The trajectory and the burst source are not just nearby, they're aligned. This alignment is geometrically profound. In astronomy, two things can appear close together in the two-dimensional dome of the sky, a condition called a projection effect, but be separated by billions of light years in depth. A distant galaxy might appear next to a foreground star, but they have no physical relationship. That's a simple and common coincidence. But when you have vector alignment, you're adding a third dimension: directionality. The path of 3 Atlas isn't just a point in Sagittarius, it's an arrow, and the evidence suggests that arrow points directly back along the line of sight to the GRB's origin. This means the two phenomena are not just coincidentally in the same line of sight from our perspective, they are plausibly located along the same line in three-dimensional space. The probability space for such a conjunction shrinks dramatically. It is no longer about two random points in a vast volume, it's about a specific line intersecting a specific tiny error volume. The odds shift from unlikely to profoundly suspect. This geometric intimacy is the first pillar of the breaking hypothesis. If GRB 25070-2b was indeed the deceleration signature of 3I Atlas, the radiation would not originate from the object's position at the time we catalogued it. Think of a supersonic jet creating a sonic boom. The boom is heard on the ground not from the jet's current position high in the sky, but from a point back along its flight path where it crossed the sound barrier, Similarly, the gamma-ray flash from a braking maneuver would emanate from a point back along the object's trajectory, from where it began its deceleration process. The light from that flash and the light from the object itself both travel at the same speed, the speed of light. But the flash happened earlier in the object's journey. Therefore, we see the flash first, from a point further away along the line of approach. Then, later, we see the object itself, which has been travelling along that same line. The geometric requirement for this scenario is perfect alignment. The GRB source must lie precisely on the incoming trajectory vector of the object, and according to the unreleased but reconstructible overlay, that is exactly what we seem to have. The mainstream counterargument rests entirely on distance. The official classification states GRB25072b is of cosmological origin, meaning billions of light years away. If that is definitively true, then the alignment is a meaningless trick of projection. 3. Atlas is in our solar system. The GRB is halfway across the universe. Their apparent alignment is no more significant than a fly in your room appearing to sit on a mountain in a photograph on your wall. This is the institutional kill shot to the hypothesis. But here's the catch. The distance to GRB25072b is not the ironclad fact it's presented as. Determining the distance to a gamma-ray burst relies on measuring its redshift by analysing the spectrum of its afterglow, the fading emission at longer wavelengths, X-ray optical infrared, that follows the initial blast. Specific absorption or emission lines in this afterglow are compared to their known rest wavelengths. The amount they are shifted toward the red end of the spectrum tells us how much the universe has expanded and thus how far away the burst is. The reports on GRB25072b, however, contain a crucial undercurrent of uncertainty. The burst's afterglow was described as unusual and structured. It didn't follow the standard smooth decay curve. Attempts to measure a redshift were made, but different teams reported different results, with low confidence. Some analyses suggested a moderate redshift, placing it at a cosmological distance. Others found the spectral features too ambiguous to call. In the dense thicket of technical literature, the distance to GRB25072b is listed not as a single number, but as a contested range, or sometimes with a question mark. The public-facing narrative solidified around the cosmological interpretation because it is the default, the safe assumption. But within the community, the door is cracked open. If the distance is not definitively cosmological, if there is even a slight chance the burst originated within our galaxy or in the local intergalactic neighbourhood, then the geometric alignment with 3 Atlas transforms from a meaningless projection into a potentially physical connection. The foreground and the background collapse into a single frame, and in that frame, the two events are not just coincidental neighbours, they are intimately linked parts of a single event. This is the silent tension at the heart of the official silence on the geometry. To publish the overlay is to visualize a question that many would prefer remained abstract. It makes the alignment undeniable and forces a direct confrontation with the distance ambiguity. It begs the question, if these two phenomena are so perfectly aligned in direction, and if the distance to one of them is uncertain, shouldn't the possibility of a local origin for the GRB be investigated with the same vigour as the standard cosmological model? The lack of a published overlay is not proof of a cover-up. It is evidence of a powerful institutional inertia, a preference to not ask questions that lead out of well-mapped territory. But geometry is a relentless truth-teller. It doesn't care about comfort. It shows us lines and intersections, and in this case, it shows us a line from an interstellar object intersecting a point of extreme energy release. This alignment alone is enough to demand a deeper look, but when we combine it with the next piece of the puzzle, the intricate overlapping timeline of these events, the case for mere coincidence begins to fracture under the weight of its own improbability. Time, in astronomy, is a layered and deceptive thing. An event's detection time is not its event time. The light we see from a distant star left it years, centuries, millennia ago. When we talk about the timing of the 3 Atlas and GRB25072b events, we are therefore not just comparing two timestamps on a calendar. We are attempting to reconstruct two complex multi-stage processes and see if their active phases intersected in a meaningful way. The official narrative presents a simple sequence: object detected on July 1st, burst detected on July 2nd, 24 hours apart, a neat, digestible gap that allows for psychological separation. But when you dissect the actual observational record, this clean separation dissolves. The timelines don't just approach each other, they bleed into one another, creating a period of overlapping activity that tightens the coincidence from a temporal near-miss into a potentially synchronized sequence. Let's begin with 3I Atlas. It was catalogued on July 1st. This bureaucratic term is crucial. It does not mean the object magically popped into existence at the inner boundary of the solar system at 0 universal time on that day. It means that on July 1st, automated survey data accumulated to a point where the system's algorithms could confidently flag it as a new, fast-moving object, and human analysts could verify its hyperbolic trajectory. The object itself had been approaching for days, weeks, possibly months prior, too faint or too strategically positioned against crowded starfields to be picked up earlier. Its detection was the moment it crossed a threshold of observability from Earth. The actual moment it entered the inner solar system, the realm where we could potentially observe its physical effects, could have been hours or even a day or two before July 1st. The catalogue date is a lower bound on its arrival time, not a precise moment of entry. Now consider GRB 250702b. Its official detection trigger fired across satellite networks on July 2nd. But gamma-ray bursts, especially long, complex ones, are rarely simple, instantaneous clicks. They often have precursors. In the hours leading up to the main gamma-ray event, orbiting X-ray telescopes sometimes detect a faint, rising hum of activity, instabilities in a collapsing stellar core, or the initial tidal stretching in a neutron star merger. For GRB 250702b, the event reports noteworthy extended X-ray precursor activity beginning in the latter part of July 1st and extending into the early hours of July 2nd. This wasn't a brief blip. It was a sustained, low-level emission that acted as a prelude to the catastrophic main event. So the gamma-ray burst sequence didn't start on July 2nd. It started while astronomers were still finalizing the paperwork on 3 Atlas. The overlay is now clear. As 3 Atlas was being confirmed as an interstellar visitor on July 1st, the source of GRB 250702b, wherever it was already ramping up, already beginning to leak energy across the light years. Their active windows were not consecutive, they were concurrent. This overlap eliminates the easiest dismissal of the coincidence. If the burst had happened a week later, one could more easily argue the two were temporally unrelated. But when the burst's precursor phase begins while the object is literally on our scientific doorstep, the two events become entangled in time. It suggests they are not independent events that happen to be near each other chronologically, but potentially two phases of a single unfolding process. There is another, more controversial layer to this timeline: ionospheric disturbances. When an intense burst of high-energy radiation from space, whether from a solar flare or an extreme cosmic event, strikes Earth's upper atmosphere, it ionizes atoms and molecules. This sudden ionization creates a detectable disturbance in the plasma of the ionosphere, which can affect the propagation of very low-frequency, VLF radio waves. A global network of amateur radio operators and scientific instruments constantly monitors these signals. For exceptionally powerful gamma-ray bursts, an ionospheric signature is sometimes detected, and it can, in theory, precede the gamma-ray detection itself. This is because the leading edge of the burst's radiation field can contain lower energy photons that travel at the same speed as gamma rays, but interact with the atmosphere in a way that produces a measurable effect slightly before the main gamma-ray flux peaks. Following GRB 250702b, scattered reports from amateur radio observers in Europe and North America described unusual sudden ionospheric disturbances, SID, beginning in the late evening of July 1st universal time. These reports are anecdotal, not peer-reviewed, and easily dismissed as local interference or equipment glitches. The professional scientific literature makes no firm mention of a correlated ionospheric event for this burst, likely due to the ambiguity of the data. But if these amateur reports are accurate, if they represent a real faint signature of the impending burst, then the effective start time of the GRB's impact on our local environment pushes even further back, deeper into the window of 3I Atlas's confirmation. It suggests the first faint tendrils of the event were touching Earth's atmosphere while our telescopes were locked onto the newly discovered interstellar object. Let's quantify the rarity we're discussing. Gamma-ray bursts are detected roughly once per day by sensitive instruments, but the vast majority are faint, short, and distant. A bright, long-duration burst like GR25702b, visible to multiple major observatories and lasting for hours, is far rarer, perhaps 1 or 2 per month across the entire sky. Interstellar objects, as we've established, are confirmed once every few years. We're talking about 2 of the rarest event classes in observational astronomy. To have them occur within a 24 to 48-hour window is by itself a low probability event, but we must now multiply that probability by the geometric alignment factor from part 2, the fact that they didn't just happen around the same time, but from the same precise direction. And now we must multiply it again by this temporal overlap factor, the fact that their active phases weren't just close but interleaved. Each multiplication shrinks the probability space of pure chance into an infinitesimally small corner. The institutional response to this temporal tightening has been to reassert the foreground-background model. 3. Atlas is a local solar system foreground event. GRB 250702b is a background deep space event. Therefore, their temporal proximity is irrelevant. They're in different layers of reality. This is a logically sound defense, but only if the layering is absolute. It is a firewall that depends entirely on the certainty of the GRB's cosmological distance. As we've seen, that distance is the linchpin, and it is not as certain as the public classification implies. If the GRB was local, within our galaxy, or even in the interstellar space just beyond our solar system, then the foreground-background firewall vanishes. The 2 events are not just coincident in our line of sight, they are coincident in space-time. They're happening in the same neighbourhood at the same time. The timeline overlap stops being an oddity and starts being a critical clue, a clue that they are causally connected, that one is the signature of the other. A clue to what? This is where speculation must be grounded in physical possibility. If the events are connected, what natural process could produce both an interstellar object and a gamma-ray burst? One possibility is that 3. Atlas is a fragment, a piece of shrapnel from the cataclysm that produced the GRB, flung out at high speed and arriving at our solar system just after the light from the explosion. But this requires the GRB to be relatively nearby, within our galaxy, and for the fragment to be travelling at a significant fraction of light speed to cover the distance in a mere day. While not physically impossible, it stretches several models to their breaking points. Another possibility is that they are both products of a larger unseen event, a disturbance that both ejected material and produced a burst of radiation. But again, this demands a local origin for the burst. Once you allow the burst to be local, however, you're forced to confront its bizarre characteristics head-on. Because GRB 250702b wasn't just any burst, its properties were so anomalous, so divorced from the standard templates of stellar death, that they point away from a simple explosion and towards something else entirely. To understand why, we must leave the realm of timing and geometry and dive into the tortured, brilliant and deeply strange heart of the signal itself. For it was in the detailed structure of those 6 hours of gamma-ray emission that the most compelling evidence for a non-natural explanation, or at the very least a non-explosive one, was written in photons of impossible energy. Gamma-ray bursts are categorized by a simple, defining metric: duration. Short bursts, lasting less than 2 seconds, are the fingerprints of binary neutron star mergers. Long bursts, lasting from 2 seconds to several minutes, are the death throes of massive stars collapsing into black holes. This dichotomy is astrophysical gospel, supported by thousands of observations. Duration tells you the engine dictates the physics. GRB 250702b did not simply challenge this taxonomy, it ignored it. Its gamma-ray emission persisted for over 6 hours. Not 6 minutes, 6 hours. This single fact catapults it out of the realm of standard long GRBs, and into a category so exotic there are only a handful of comparable events in the entire history of astronomy. Its duration alone signals that whatever produced it was not a one-time catastrophic release, but a sustained energy generation process. But the strangeness is not merely in the stopwatch, it's in the shape of the emission. A standard gamma-ray burst from a collapsing star is fundamentally an explosion. It has a characteristic light curve, an incredibly sharp, intense spike, the initial catastrophic release, followed by a rapidly decaying afterglow as the shockwave expands and cools. The energy is front-loaded, violent, and brief. GBP507002b did not spike, it ramped. The emission began at a low level, increased gradually over the course of an hour, plateaued at a high but steady intensity for several hours, and then finally began a slow decline. This is not the signature of a detonation. It is the signature of a system powering up, achieving operational equilibrium, and then powering down. Explosions don't warm up, they go off. The structured emission profile noted in the reports refers directly to this non-explosive, controlled seeming rise and fall. It's a profile that speaks of regulation, of an energy source being fed and managed, not of a fuel supply being instantly and catastrophically consumed. Within this sustained emission, analysts found further layers of complexity. The light curve was not smooth. It exhibited intensity fluctuations and brightness variations. In a natural explosion, you might expect some irregular bumpiness due to clumpiness in the ejected material or instabilities in the shock front. But the fluctuations in GRB 250702b were described with another carefully chosen word, quasi-periodic. This means they were not random noise. They exhibited a rough rhythm, a repeating pattern of peaks and troughs with a preferred timescale. The pulses weren't metronomic like a perfect clock, but they clustered around a regular interval with a degree of consistency that chaotic astrophysical plasmas are notoriously bad at producing. Imagine the difference between the sound of rain on a roof, a stochastic random patter, and the sound of a drumbeat, even an improvised one. The rain is governed by statistics. The drumbeat implies an agent, a structure, a purpose behind the timing. To many who studied the light curve, GRB25-ROYUSEM-02b sounded more like drumming than rain. Duration and structure together point to the nature of the energy reservoir. A 2-second burst implies a finite fuel supply that is exhausted almost instantly, a stellar core collapsing, a neutron star merging. A 6-hour sustained emission implies a deep, continuously tapped energy reserve, or a process that efficiently converts an external source of energy over a long period. In standard astrophysics, the only way to power something for that long is through accretion, material falling into a black hole or neutron star, converting gravitational potential energy into radiation as it spirals in. But accretion disks have their own signatures, specific thermal spectra, predictable evolution. The spectral data from GRB 250702b did not cleanly match these expectations. The engine, if it was accretion, was either profoundly unusual or obscured in a way that masked its standard features. This leads us to the critical distinction between explosive and directed energy release. An explosion radiates energy more or less equally in all directions, isotropically. A directed energy source, like a lighthouse beam or a rocket exhaust, focuses its output along a specific axis. Relativistic beaming, a well-understood effect of Einstein's special relativity, does exactly this. Any object moving at a significant fraction of light speed will have its emitted radiation focused into a narrow cone pointing ahead of it. This is why astrophysical jets from black holes can appear blindingly bright from certain angles. They're not generating impossibly more energy, they're simply focusing what they have like a cosmic spotlight. If GRB 250702b was produced by a relativistic object breaking, its radiation would be intensely forward-beamed. We would see it only because we happen to be looking directly down the barrel. Its sustained high intensity would be a consequence of this beaming, not necessarily of an impossibly powerful engine. Now, synthesize the anomalies. We have a gamma-ray event of unprecedented duration. It doesn't explode, it ramps up and down in a controlled manner. Within this sustained emission, it pulses with a quasi-regular rhythm. Its energy appears forward-directed. These are not the characteristics of a star dying, but they are hauntingly consistent with the signatures of a controlled, technological process. If you were an engineer tasked with designing a system to decelerate a massive object from relativistic speeds, you would face a brutal physics problem: how to dissipate an astronomical amount of kinetic energy without vaporizing your vehicle. The answer would likely involve converting that kinetic energy into radiation and ejecting it. You would want the process to be controlled, not explosive, a sustained burn, not a bomb. You might pulse your braking systems to manage thermal loads or to allow for course corrections. The resulting exhaust would be a directed beam of the most energetic radiation possible, gamma rays, blasting ahead of your craft along your line of flight. To an observer in the beam's path, it would look exactly like a long-duration structured pulsing gamma ray burst. It would look, in fact, exactly like GRB 250702b. I must pause here to emphasize this point is not a leap to aliens, it is an exercise in comparative physics. We are taking a set of observed characteristics and asking what known physical processes could produce them. Natural astrophysics offers some strained options: an extremely rare and long-lived accretion event, a magnetar with unprecedented activity, a tidal disruption event viewed from a perfect angle. These are all possible, but they require stacking unusual modifiers upon rare events. The breaking hypothesis, while extraordinary, provides a single, coherent framework that explains all the anomalous features simultaneously. The duration, breaking takes time, the ramp, systems powering up, the pulsing, modulated thrust, the forward beaming, relativistic motion, and, crucially, the geometric and temporal link to 3i Atlas, the bullet following the flash. The mainstream will rightly argue that extraordinary claims require extraordinary evidence, and a single strange burst, even with coincidences, is not enough. They will fall back on the principle of mediocrity. It's more likely to be an unusual natural event than a technological one. And they are correct. By the sheer weight of precedent, natural explanation should be preferred. But science does not progress by preference. It progresses by following the evidence, even when it leads to uncomfortable places. The unusualness of GR 7002b is not a minor footnote. It is a fundamental challenge to classification, and when that unusual event is inextricably linked via timing and geometry to another ultra-rare event, the coincidence explanation itself begins to require an extraordinary run of statistical luck. The individual strangeness of each event compounds the strangeness of their conjunction. But to fully grasp why this pulsing structure is so provocative, why it moves the discussion from unusual astrophysics into a territory that sends institutional shivers down the spine, we must examine the nature of the rhythm itself. For in the precise spacing of those pulses lies a potential message, not necessarily one of language, but one of intent. A stochastic universe does not create rhythms without a reason. A rhythm implies a mechanism that counts, that repeats, that modulates. It is the fingerprint of a system under control, and when we analyze that fingerprint with the tools of signal processing, we find that it doesn't just suggest structure, it statistically resembles it. This brings us to the most sensitive and compelling layer of the mystery, the signal within the signal. Chaos is the native state of cosmic violence. In the heart of a supernova, in the maelstrom of a neutron star collision, matter is compressed to nuclear densities, magnetic fields are wound into impossible knots, and shock waves propagate through turbulent plasmas. From such environments, we expect the light curves we observe to be stochastic, noisy, irregular, unpredictable. They are the fingerprints of complex systems pushed far beyond equilibrium. Clean signals, regular patterns, and steady rhythms are the hallmarks of ordered systems: rotating pulsars, orbiting planets, vibrating stars. GRB 7002b presented a paradox. It was an event of immense violent energy, yet its emission contained a whisper of order. The quasi-periodic pulses were not an illusion. Multiple independent teams, applying standard signal processing techniques like Fourier, transforms and autocorrelation analysis to the gamma-ray light curve, detected a statistically significant signal. The intervals between major emission peaks were not randomly distributed. They clustered around a preferred timescale, with a consistency that exceeded what one would expect from a purely chaotic process. This finding immediately triggers the human brain's most powerful and most dangerous faculty, pattern recognition. We are wired to see faces in clouds and messages in static, apophenia. The scientific guard against this is rigorous statistical testing. The tests applied to GRB 250702b's pulse timing suggested the pattern was real, not an artifact of binning data or wishful thinking. The papers that discussed it were laden with cautious language. Suggestive of non-random structure, warrants further investigation, consistent with a quasi-periodic oscillator. But the core result stood: there was a rhythm in the roar. In natural astrophysics, quasi-periodic oscillations, QPOs, are known phenomena. They arise in accretion disks around black holes and neutron stars, where blobs of hot gas orbit at specific resonant frequencies, creating a flickering in the X-ray emission. They are seen in pulsating variable stars, but these QPOs have specific properties. They are often linked to a particular spectral state. They appear in specific energy bands, usually X-rays, not the brutally hard gamma rays of a GRB, and they have characteristic relationships between frequency and intensity. The QPO detected in GRB 25702b did not neatly match these templates. It was broader, present in the highest energy data, and persisted throughout the 6-hour event. It was a rhythm, but not one easily explained by any standard astrophysical clock. This is where the conversation, often held in hushed tones at conference coffee breaks, but absent from formal proceedings, turns to the language of information theory. A rhythm is a carrier of information. The simplest communication systems use timing to encode data. Morse code is a series of timed pulses. The regularity of a pulse repetition rate, PRR, in a radar or LiDAR system is a deliberate engineered choice to distinguish the signal from noise. The search for extraterrestrial intelligence, CT, has, for decades, been predicated on this principle, that an artificial signal will contain structure, narrowband frequency, precise pulse timing, unusual modulation that distinguishes it from the broadband, stochastic emission of natural sources. The famous wow signal was compelling precisely because it was a narrowband spike, an anomaly in the radio noise. Gamma-ray SETI is a nascent and fringe idea, primarily because generating coherent modulated gamma-ray signals requires energies and technologies far beyond our own, making it seem implausibly wasteful. But implausibility is not impossibility. And if the goal is not routine chatter, but a powerful, unmistakable one-time activation signal, or a signature that must penetrate dust and ignore magnetic fields, gamma rays have distinct advantages. They travel in perfectly straight lines, they are not easily scattered, and their detection is unambiguous. A gamma-ray photon of that energy means business. If you wanted to send a wake-up call or a beacon across interstellar space, and efficiency was secondary to certainty, a pulsed gamma-ray burst is a logical solution. The pulses themselves could be a simple "I am here" signal, or they could encode more complex data in the intervals between them, a binary sequence etched into time itself. I'm not claiming Group 50702b was such a signal. I'm highlighting the uncomfortable congruence. We have an event with a statistically non-random pulse structure. This structure is difficult to explain with standard astrophysical oscillators. The event is perfectly aligned in time and space with the arrival of an interstellar object. This combination of facts forces a spectrum of interpretations. At the conservative end, it's an extremely unusual natural oscillator we don't yet understand. At the radical end, the structure is a product of engineering, a signature of control embedded in the braking process, or a message encoded within it. The scientific establishment, for entirely valid reasons of caution and precedent, clusters tightly at the conservative end, but the data pulls, gently but insistently, toward the middle. Why does this matter? Because if the rhythm is engineered, even partially, then the entire framework for interpreting the event flips. It is no longer a question of what exploded, but of who or what was braking or signalling or both. The pulse timing becomes a functional component, not a curious byproduct. It suggests the energy release was modulated according to a plan to manage thrust, to communicate, or to achieve some other operational goal. In the context of the braking hypothesis, pulsing makes perfect engineering sense. A continuous maximum thrust deceleration could generate unbearable thermal stress. Pulsing the thrusters allows for heat dissipation, for course correction between pulses, for system checks. The resulting exhaust plume would naturally produce a structured rhythmic gamma-ray signature. The institutional reluctance to entertain this line of thinking is not a conspiracy. It is a firewall. The firewall exists because the step from unusual natural event to potentially artificial is a professional cliff. Once you publish a paper seriously considering an artificial origin, your career becomes tied to that most perilous of scientific pursuits, the search for extraterrestrial intelligence, where false positives are legion and definitive proof is elusive. It is safer by far to continue proposing ever more exotic natural models, a supernova inside a nebula inside a magnetic funnel, than to utter the A word. This firewall, however, can sometimes block legitimate inquiry. It creates a situation where anomalous data is forced into natural categories that don't quite fit, and where alternative frameworks are stigmatized before they can be properly evaluated. The rhythm of GRB 2507V2b is the sharpest thorn in the side of the natural explanation. It is the feature that most stubbornly resists being smoothed away into the noise of cosmic chaos. It is why this event, among thousands of other transients, continues to generate underground discussion. It is why, when you look at the stacked anomalies, the timing, the geometry, the duration, the structure, a pattern of 3 begins to emerge not just in the pulses, but in the very architecture of the event itself. This pattern, a cognitive beacon for human minds, becomes our next point of investigation, for it may be the key that ties the bullet, the flash, and the coming moment of reckoning into a single, terrifyingly coherent story. Human cognition is built upon a scaffolding of 3s. It is the minimum number required to establish a pattern, to move beyond isolated data points and coincidental pairs into the realm of a trend. 3 acts structure our stories, 3 trials test our heroes, 3 points define a plane. In the data surrounding the events of July 2025, the number 3 recurs with a frequency that feels less like coincidence and more like a structural element. It is a cognitive echo that amplifies the signal within the noise, demanding that we pay attention not to mysticism, but to the possibility of deliberate architecture. The rule of 3 in this context is not numerology. It is a potential fingerprint of redundancy, of phased execution, and of a minimum sufficient set. The most obvious and foundational 3 is in the catalogue itself, 3i Atlas. It is the 3rd confirmed interstellar object. Oumuamua, 1i, was the first, the baffling pioneer that challenged our models. Borisov, 2i, was the second, the more conventional comet that confirmed the population. 3 Atlas is the 3rd, the heir to this newly established lineage. 3 of these profound rarities within an 8-year window shifts the paradigm from that weird thing that happened once to this is something that happens. It establishes a statistical baseline, but it also marks a cognitive threshold. 1 is an anomaly, 2 is a pair, 3 is a category. Our minds are now primed to look for meaning in this 3rd visitor. This pattern of 3 extends into the gamma-ray burst itself. Different analytical approaches to dissecting the 6-hour light curve of GRB 2507-2b yield varying numbers of distinct pulses depending on sensitivity thresholds and definitions. However, several independent analyses converge on a specific segmentation: 3 primary emission episodes, 3 distinct peaks of intensity separated by quieter periods rising from the sustained plateau. These are not minor fluctuations but major energetic events within the larger event. The burst, in essence, had a trilogy embedded within it, a beginning, a middle, and an end within its prolonged emission. Furthermore, the much-discussed quasi-periodic timing often cited a recurrence interval that, when applied to the burst's duration, naturally suggested a 3-phase internal structure. Now overlay the timeline. Viewed from a sufficient height, the sequence from July 1st to July 2nd partitions neatly into 3 distinct phases, each with its own character. Phase 1. Detection and initialization. July 1st. 3. Atlas is catalogued, entering humanity's scientific awareness. Concurrently, the X-ray precursor activity for GRB 2507-2b begins. The interstellar object is confirmed as the burst engine starts its preliminary hum. Phase 2, the main event. Early to mid-July 2nd, the gamma-ray burst reaches its sustained pulsing peak, radiating its impossible energy for 6 hours. The main deceleration maneuver, or the primary signal transmission, is executed. Phase 3, aftermath and transition. Post-July 2nd, the burst fades, leaving an unusual afterglow. The Atlas, now under intense scrutiny, begins to exhibit its own suite of subtle anomalies, spectral shifts, possible plasma emissions, the signs of an object in a new state. 3 phases: arrival, initiation, execution, and consequence. Before we proceed, the danger must be acknowledged. The human brain is a pattern-imposing engine as much as a pattern-recognizing one. We are adept at grouping things into 3s because it's a satisfying, manageable number. We could likely force a narrative of 4s or 5s with equal effort. This is the seduction of numerology, and it is a trap we must consciously avoid. The significance is not in the number 3 as a magical integer. but in the recurrence of a tripartite structure across independent dimensions of the phenomenon: the object count, the burst's internal structure, and the event timeline. When the same minimalist pattern emerges from the object, the signal, and the sequence, it ceases to be mere apophenia and starts to look like a design principle. In engineering, triplicate structures are fundamentally about reliability and phasing. Redundancy is the cornerstone of robust systems. One component can fail. Two components can fail in a common mode. Three provides a buffer, allowing for fault tolerance and continued function. Critical communication protocols often use triple redundancy for essential data. In complex maneuvers, a three-phase plan is standard: preparation, execution, and verification. If 3i Atlas were an engineered artifact, and if GRB25072B were its arrival signature, a three-phase activation is not just plausible, it is optimal. Phase 1. Terminal approach and system wake-up, precursor X-rays object detection. Phase 2, primary braking burn or main beacon activation, sustained gamma-ray emission. Phase 3, post-maneuver stabilization and mission mode initiation afterglow object activity changes. 3 phases because that is how you reliably orchestrate a complex high-stakes operation across light years. The question therefore is not, is 3 a special number, but why does this particular event attract this specific pattern analysis so intensely? Astronomers process thousands of anomalies. Most are filed away after being squeezed into existing categories. What makes the July 2025 sequence different is the convergence. It is not one strange thing. It is a cluster of strange things that are also anomalously linked by space and time. Our pattern-seeking brains latch onto the simplest repetitive element within that convergence, the triplet structure, as a handle to grasp the whole. But the real weight lies in the fact that there is a convergence at all. The rule of 3 here is a symptom of a deeper anomaly, the tight coupling of multiple rare events. It is a sign that we're not looking at scattered oddities, but at a coherent if deeply mysterious package. This coherence leads us inevitably to the physics that could bind these 3-part events together. If the gamma-ray burst was the flash, and 3i Atlas is the bullet, then the connecting tissue is motion at the most extreme velocities the universe allows. To understand what we might have witnessed, we must move from pattern recognition to the brutal, elegant laws of relativistic mechanics. We must ask what happens when the universe's speed limit is not just approached but utilized, and what kind of signature is left behind when something that has ridden that limit decides, against all natural inclination, to stop. The answers are written in equations over a century old, and they paint a picture of energy release so monumental it can mimic a star's death. This is not speculation about unknown physics. It is the application of known physics to a scenario that nature, left to its own devices, may never create. The physics of near-light speed travel is not gentle. It is governed by the unforgiving mathematics of Einstein's special relativity, where velocity is paid for with exponentially increasing energy. This is not science fiction. It is the operational reality of our largest particle accelerators. An electron accelerated to 99.9% of light speed carries kinetic energy thousands of times greater than its mass energy at rest. Scale this up. Imagine an object with tangible mass, a gram, a kilogram, a ton, moving at such velocities. The kinetic energy it stores becomes astronomical, a numerical nightmare. For an object to slow down from such speeds, to break, it must dissipate this mountain of energy. It cannot simply frictionally stop. There is no medium thick enough. The energy must be converted and ejected. This is the core of the relativistic braking hypothesis. To decelerate, the object must become a radiator. It must transform its devastating kinetic energy into electromagnetic radiation and propel that radiation away. The most efficient way to shed vast amounts of energy quickly is to emit the highest energy photons possible, gamma rays. Therefore, the deceleration signature of a relativistic spacecraft would, of necessity, be a gamma ray source, but not a random one. The physics dictates its precise character. First, duration. Breaking from a significant fraction of light speed cannot be instantaneous. It would require a prolonged thrust, a sustained application of force to counteract the monumental momentum. This translates to a sustained energy release. The braking burn could last hours, days, or longer, depending on the desired deceleration and the system's capabilities. A 6-hour gamma-ray emission is not only plausible. For a massive object, it might be the minimum. Second, beaming. An object moving at relativistic speeds does not radiate evenly in all directions. Due to the relativistic headlight effect, its emitted radiation is focused into a narrow cone pointing directly along its direction of motion. This is a proven phenomenon observed in astrophysical jets. Consequently, the gamma-ray exhaust from a braking maneuver would be a highly collimated beam, blazing ahead of the craft like a cosmic lighthouse beam. Only observers situated within this narrow cone would witness the full, terrifying brilliance of the deceleration. We, on Earth, would have to be fortuitously, or deliberately, positioned in the crosshairs. Third, modulation and structure. A controlled braking process would not be a simple, monotonous blast. Engineering constraints would demand modulation. Thrusters might pulse to manage thermal load, to allow for navigational corrections between bursts, or to perform system diagnostics. This pulsed operation would imprint a quasi-periodic structure onto the gamma-ray emission, a rhythmic on and off pattern within the sustained beam. The structure would not be perfectly metronomic, real systems have feedback and adjustment, but would show statistical regularity, a rhythm distinct from explosive chaos. Now, superimpose this theoretical signature onto the observed properties of GRB 2500702b. A sustained emission lasting 6 hours. Check. A signature consistent with forward beaming, as inferred from its anomalous brightness and structure. Check. A complex, quasi-periodic pulse structure within that emission. Check. The braking hypothesis predicts exactly the trio of anomalies that made this burst so unusual. It provides a single, parsimonious framework that explains the duration, the directionality, and the rhythm not as separate puzzles, but as interconnected features of a single process. Controlled, relativistic deceleration. Contrast this with natural explanations. To explain a 6-hour gamma-ray event, astrophysicists must invoke extreme and rare scenarios. A magnetar hyperflare of unprecedented duration, a star being slowly shredded over hours by an intermediate black hole, a tidal disruption event in slow motion, or a failed supernova with a protracted collapse. Each of these struggles, magnetar flares are energetic but typically shorter and have different spectral signatures. Tidal disruptions can be long but usually produce more X-ray and UV emission than hard gamma rays. A protracted collapse doesn't explain the clean pulsing. Each natural model can explain one or two anomalies only by becoming increasingly baroque and ad hoc. The braking hypothesis, while extraordinary, explains all three elegantly and simultaneously. Furthermore, the hypothesis makes a clear prediction about sequence. The radiation from the braking event travels at light speed. The light from the object's physical structure also travels at light speed, but it's emitted continuously from the object's position along its trajectory. The braking radiation we see comes from a point further back along that trajectory, from when braking initiated. Therefore, we see the brilliant gamma-ray flash first. Then, after a delay corresponding to the light travel time from the object's newer, closer position, we see the object itself. Flash, then bullet. GRB 250-702b, then 3 Atlas. The 24-hour gap is not a random interval, it is a potential light travel delay, a direct consequence of the physics involved. It is critical to state what this hypothesis does not require. It does not require warp drive or violations of known physics. It uses standard relativistic mechanics and thermodynamics. It does not require the object to be manned or even conscious. It could be an autonomous probe. The truly staggering implication is not the physics, but the implication of the physics, that a process which does not occur naturally, the controlled, high-mass relativistic deceleration, appears to have occurred. Nature does not build brakes. Asteroids, comets, and stellar fragments do not decide to slow down as they enter a star system. They obey gravity and inertia. The presence of a braking signature is by definition a signature of non-natural, or more precisely non-passive agency. It is the fingerprint of technology. This is the professional event horizon that most researchers will not cross. Suggesting an artificial origin is the ultimate career risk in astronomy. It is why the conversation remains locked on straining natural models, even as they buckle under the weight of the data. But we must follow the logic where it leads. if the signature fits the braking model with uncomfortable precision, and if the natural alternatives are contrived and incomplete, then the possibility must be entertained, if only to be rigorously tested. And the test is not philosophical, it is observational. If 3 Atlas is the bullet that followed this gamma-ray flash, its subsequent behaviour should reflect an object that has recently undergone a profound change in status. It should not look like a simple, inert rock. We must now turn our telescopes away from the fading echo of the burst and train them with renewed intensity on the object itself, for in the subtle whispers of its light may lie the evidence that it too is part of the machine. If the gamma-ray burst was the arrival signature, then 3I Atlas is no longer merely a subject of astrometric and spectroscopic study. It becomes the central artifact in a potential first contact scenario. The immediate question shifts from what is it made of to what is it doing? Following the July 2nd event, the observational focus on 3 Atlas intensified, but within the standard framework of characterizing an interstellar object. The data that emerged from this scrutiny did not reveal flashing lights or radio transmissions. Instead, it offered a more subtle, more scientifically tantalizing profile, an object that refused to behave like a simple, inert piece of cosmic debris. Its post-burst behavior was characterized by a suite of low-level anomalies that, while explainable individually by exotic natural chemistry, collectively paint a picture of something active. The primary tool for this investigation is spectroscopy, dissecting the sunlight reflected from or emitted by the object into its constituent colours to reveal its compositional fingerprint. Early spectroscopy of 3 Atlas suggested a surface similar to some carbon-rich asteroids or cometary nuclei, but with puzzling unidentified absorption features. This, alone, was not shocking. It came from an alien star system with different chemical abundances. However, subsequent spectral observations taken in the weeks after July 2nd reported subtle but detectable changes. Certain faint emission lines not initially present seemed to appear. The shape of absorption bands shifted slightly. These changes were not dramatic, but they were noted in internal team reports and circulated among specialists. On a comet, such changes are expected as new ices are exposed to sunlight and sublimate. But 3I Atlas was far from the Sun, at a distance where solar heating is minimal. The observed spectral shifts were larger than standard thermal models for its location would predict. Concurrent with the spectral whispers were reports of photometric colour shifts. By measuring the object's brightness through different coloured filters, astronomers can gauge its colour index. Is it red, blue, neutral? 3I Atlas exhibited small, erratic variations in its colour. More intriguingly, these variations seemed somewhat correlated with its rotation period. This suggests that different regions of the object's surface have different reflective properties, and that these regions are not uniformly distributed. An inert, weathered rock tends to have a homogeneous colour. A comet's activity is usually more global, creating a diffuse coma. Patchy, rotation-linked colour variation hints at surface heterogeneity, possibly of an engineered kind, or at very localized outgassing from specific vents. Perhaps the most technically compelling and controversial post-burst reports concerned sporadic, faint emission lines consistent with low-density plasma. Plasma is ionized gas, and its spectral signature is distinct. For a comet, a plasma tail forms when solar UV radiation ionizes gases in its coma, but again, 3 Atlas was too distant for strong solar ionization, and it showed no visible coma or dust tail. The suggestion of plasma emission therefore implies an internal ionization source. Frictional heating with a tenuous interplanetary medium is far too weak. Could it be residual heat from a recent high-energy process? Or perhaps low-level intermittent electrical activity? These reports remain unconfirmed and hotly debated, as the signals are at the very edge of detection. But their mere suggestion in the context of the other anomalies is profoundly significant. Then there is the question of trajectory. The published orbit for 3I Atlas is a pure gravity solution, a hyperbolic path dictated by its velocity and the Sun's gravity. However, as tracking continues with high precision, there is always room for tiny residuals, the differences between the predicted path and the actual observed positions. For most asteroids, these residuals are noise, stemming from imperfect measurements or unmodelled tiny forces like solar radiation pressure. In private discussions, some orbital dynamicists have noted that the residuals for 3i Atlas are slightly larger than expected, and they don't perfectly randomize. They show a weak trend. This could indicate non-gravitational acceleration, a tiny thrust. Comets exhibit this due to asymmetric outgassing. If 3i Atlas is outgassing, even minutely to produce the spectral and colour changes, then a non-gravitational acceleration is expected. The problem is the magnitude. The spectral changes are so faint that the outgassing required to produce them should be minuscule, likely too small to produce the rumoured trajectory deviations. The reported deviations, if real, would require a more potent or more directed force. Let's be unequivocal, none of this is proof of artificiality. Each anomaly, the spectral shifts, the colour variations, the plasma hints, the orbital whispers, has a potential natural explanation. Unusual chemistry could cause strange spectral lines. Patchy ice deposits could cause colour variation. A chance interaction with a solar wind current sheet could cause a spurious plasma signal. Orbital residuals are notoriously tricky, but we are back to the problem of compounding coincidences. Is it likely that an interstellar object, already a rarity, would also have hyper-unique chemistry that causes changing spectral lines and patchy surface deposits, and chance plasma interactions and tricky orbital residuals, all while having arrived within a day of a bizarre gamma-ray burst from its exact approach vector? The natural explanation now requires a cascade of independent unlikely traits. This is where the activation hypothesis offers a coherent alternative. Imagine GRB 250702b was not only a breaking signature, but a wake-up call. A directed, pulsed gamma-ray beam, engineered to penetrate dust and ignore interference, carrying a specific command or activation code to a dormant probe within our solar system. 3i Atlas receives this signal. Its internal systems, dormant for an eon, power on. This activation sequence might involve initializing internal power systems, causing minor surface heating and localized outgassing of contaminants, explaining spectral shifts, deploying or activating external sensors or structures with different albedos, explaining patchy color changes, creating low-level electrical activity or plasma sheaths for communication or propulsion, explaining the plasma hints, and executing minute trajectory corrections to assume its operational orbit, explaining non-gravitational residuals. In this framework, the post-burst anomalies are not random noise. They are the expected boot-up sequence of a complex machine coming online. The activation hypothesis is distinct from, but compatible with, the breaking hypothesis. They could be separate events, a wake-up call followed later by arrival, or they could be combined. The breaking is the activation signal, a multi-purpose energy dump that both slows the craft and transmits commands. This gets to a principle of likely interstellar engineering, efficiency of action. Why waste energy on separate systems when one high-energy event can achieve multiple objectives: deceleration, communication, and system activation? The institutional response to these post-burst observations has been to study them as an unusually active interstellar object. The papers are written with titles like Spectroscopic Evolution of 3i Atlas and Photometric Variability of an Interstellar Visitor, carefully staying within the safe taxonomy. The deeper question, could these changes be correlated with the GRB, is rarely posed in print, as it crosses the boundary into speculation that funding committees and journal editors frown upon. Yet, the observations continue. Telescope time is allocated. Because regardless of the framework, the object is demonstrably weird, and in science, weirdness is its own justification for scrutiny. This scrutiny is now folding into a larger, more unsettling trend in 2025 astronomy, one where the tools of observation are beginning to outpace the frameworks for understanding. The anomalies are not just surrounding 3i Atlas, they are proliferating across the sky, and our new non-human partners, artificial intelligences, are starting to point out connections that our own institutional blinders have caused us to miss. Science is not a pure abstract pursuit of truth. It is a human endeavour conducted within institutions. These institutions, universities, funding agencies, journals, professional societies, have rules, incentives, and social dynamics that powerfully shape what questions get asked, how they are investigated, and what answers are deemed acceptable. This is not a critique of corruption, but an acknowledgement of reality. The system excels at incremental progress within established paradigms, refining the model of stellar evolution, cataloguing exoplanet types, mapping galactic structure. It stumbles, often catastrophically, when confronted with data that threatens to overturn the paradigm itself. The case of 3 Atlas and GRB 250702b sits directly on this fault line. The institutional reflex is classification. When a new object is discovered, the first step is to assign it to a known category. This is pragmatic. It determines which observational protocols to use, which theoretical models to apply, and which colleagues will be interested. 3I Atlas was classified as an interstellar object, likely asteroidal with possible cometary activity. This classification funnels research toward measuring its orbit, rotation, and composition. It does not funnel research toward analysing its surface for geometric patterns, searching for radio emissions, or correlating its behaviour with deep space transients. Those questions lie outside the categories box. To ask them is to risk being seen as unscientific, as a speculator, as someone chasing little green men. The career penalties are real. Difficulty publishing, denial of telescope time, sidelining at conferences. We've seen this before. When pulsars were discovered in 1967, their stunningly regular radio pulses led the discoverers to briefly label them LGM-1 for little green men. It was a joke, but one born of genuine bewilderment. The scientific community breathed a collective sigh of relief when the natural model, a rotating neutron star, was successfully applied. The artificial hypothesis was discarded not because it was disproven first, but because a satisfactory natural explanation was found. The system worked, but it also established a template: treat potential artificial signals as a humorous last resort until a natural explanation is forced upon you. The problem arises when the natural explanations become increasingly strained, yet the artificial hypothesis remains professionally toxic. GRB 250702b suffered the same categorical fate. It was immediately classified as a natural gamma-ray burst, albeit an unusual one. This classification acted as a cognitive firewall. It directed analysis toward exotic astrophysical models, unusual magnetars, slow tidal disruptions, and away from analyses common in SETI, searching for information content in the pulse timing, analysing the polarization for engineered patterns, or seriously modelling it as a directed energy signature. These latter analyses are not forbidden, but they receive no funding, no official encouragement, and lead to papers that top-tier journals will reject as too speculative. The burden of proof is asymmetrical. Proponents of a natural explanation need only suggest a plausible, if rare, scenario. Proponents of a non-natural explanation must definitively rule out all natural possibilities, an impossible task with a single, non-repeating event. This institutional inertia is now colliding with a technological tsunami, the era of big data astronomy and machine learning. In 2025, wide-field survey telescopes scan the entire sky every few nights. Automated pipelines flag millions of transient events, things that change brightness, move, or appear. The volume of data is far beyond human capacity to sift through. The solution has been artificial intelligence. Algorithms are trained on historical data to classify new transients. This is a supernova, that is a variable star, this is an asteroid. But these AIs do something else, something profoundly important. They identify outliers, events that don't fit any known category. And they don't just find them one by one, they cluster them. They find that certain outliers share strange features with each other, forming new tentative groups that human classifiers never defined. This is where the story expands beyond our 2 July actors. Throughout 2025, AI systems processing data from surveys like the Legacy, Survey of Space and Time, LSST, and gamma-ray monitors have been flagging a growing cluster of long-duration structured high-energy transients. These are events lasting hours, with complex light curves, sometimes with quasi-periodic features. They are not standard GRBs, not standard supernovae, not standard anything. GRB 250702b is a prime, extreme member of this AI-identified cluster. The machines are telling us, in their silent statistical way, that what we witnessed in July is not a unique monster, but part of a population our human-designed categories have failed to recognize. The institutional response to this AI-driven discovery is telling. There is excitement about discovering a new class of astrophysical transients. Papers are being drafted proposing new natural engines, supermagnetars, hybrid accretion events, peculiar pair instability supernovae. The conversation is firmly within the natural paradigm sandbox. The possibility that this AI-identified cluster might represent something other than a new astrophysical class is not entertained in polite company, yet the question hangs in the air, asked by the data itself. If these events share engineered seeming features, long duration, structure, pulsing, and if they are being detected at a rising rate, what does that imply? It implies that our observational net is now fine enough to catch phenomena that were always there but too rare or too strange to be noticed. Or more disruptively, it implies that the frequency of these phenomena is increasing. Couple this with another AI-noted trend. The detection rate of interstellar objects is also climbing faster than pre-Oumuamua models predicted. We are seeing more of them, and we are seeing more strange long-duration transients. Are these two trends independent, or are they facets of the same new reality, an increase in traffic through our solar neighbourhood? The institutional firewall is struggling to contain this. AI has no career fears, no professional taboos. It simply finds patterns. It is now flagging correlations humans would never dare to look for. The next step, already happening in closed-door workshops and on private servers, is to have AI cross-correlate these two outlier clusters, the strange transients and the interstellar objects. Does the appearance of one sometimes coincide with the other? Do they share directional biases? This is the analysis that could blow the firewall apart, and it is coming, not from a rogue scientist, but from the logical, unbiased output of our own data processing tools. We stand at an inflection point. The old system, reliant on human categorization and conservative consensus, is being bypassed by a flood of data and the agnostic pattern recognition of machines. The anomalies of July 2025 PIF3 Atlas and GR+2b are no longer just a curious pair. They are the brightest flashlights yet shone into a much larger, darker room full of similar oddities. The institutions can continue to file each new one under increasingly contrived natural categories, but the AI clusters are a map of a territory that doesn't fit the old map. And this brings us to the precipice of a prediction. If there is a pattern, if this activity is coordinated or signified, then it might align with natural, predictable celestial milestones. It might use the cosmos itself as a clock, and in the immediate future, a unique cosmic clock is about to strike a rare hour. Predictive power is the gold standard of a scientific hypothesis. Anyone can concoct a story to explain past events. A real theory sticks its neck out and predicts what should happen next. The framework built from the July 2025 events, the breaking activation hypothesis linked to 3i Atlas, makes a bold, falsifiable prediction. It points to a specific date in the near future and says, watch here, at this time, for correlated activity. That date is January 2026. The prediction is based on a simple astronomical fact, a rare planetary alignment. Alignments themselves are not mystical. They are geometric coincidences of orbital periods. In January 2026, 5 planets, Mercury, Venus, Mars, Jupiter, and Saturn, will converge in a relatively tight grouping in the pre-dawn sky. This specific configuration, with these planets in these relative positions, occurs roughly once every 2 centuries. From an external observer's point of view, this alignment creates a unique, unmistakable line-of-sight signature within our solar system. It is a natural galactic-scale timestamp. If you were an external civilization coordinating probes across light years, or if you had sent a wake-up signal in July, when would you schedule the next phase of operations? You would choose a time that is unambiguous, a moment that any observing system within the solar system could independently identify without synchronized clocks. A rare planetary alignment is a perfect synchronization marker. It's a cosmic on January 26th, written in the language of orbital mechanics. The 6-month gap between the July gamma ray burst and the January alignment is a reasonable buffer, time for an activated probe to position itself, run diagnostics, and prepare for whatever its mission dictates. So the prediction is clear. If the July events were part of a deliberate, coordinated operation, we should expect observable activity correlated with the January 2026 alignment. What would that look like? It could take several forms, all testable. 1. New detections. The arrival of new interstellar objects, perhaps smaller companions to 3i Atlas, whose trajectories are timed to reach perihelion or a specific solar system location during the alignment. 2. Behavioral changes. A marked shift in the activity of 3i Atlas itself, a change in its rotation, a new spectral emission line, a distinct maneuver altering its trajectory. 3. New signals, another transient event, perhaps another structured gamma ray or X-ray burst, originating from the direction of 3i Atlas or from its original radiant point, timed to coincide with the alignment. 4. Unforeseen phenomena, something entirely new, something our current categories don't describe, that clusters around this date. Conversely, if January 2026 comes and goes with nothing but the silent, predictable procession of planets, the hypothesis suffers a major, perhaps fatal, blow. The alignment would then be just another coincidence in a growing pile, and the entire elegant structure of interconnected anomalies would likely collapse back into the realm of staggering but ultimately meaningless statistical flukes. The natural explanations, however contrived, would regain the upper hand by default. This is the beautiful, ruthless logic of science. The universe will cast the deciding vote. But even if January passes quietly, the larger questions raised by the 2025 data will not disappear. The AI identified clusters of long-duration transients and the rising count of interstellar objects are objective facts, independent of any interpretation of July. Our sky's becoming stranger, or we're finally seeing its true strangeness. The institutional framework is cracking under the data load. The old categories are insufficient. We are being forced, by the relentless output of our own telescopes and algorithms, to consider possibilities we have long relegated to fiction. Let's reassemble the stack one final time with January in mind. We catalogued the third interstellar object. A day later, a 6-hour, structured, pulsing gamma-ray burst erupted from its precise approach vector. The burst's characteristics defy standard explosive models, but match the expected signature of relativistic braking. The object subsequently exhibited subtle signs of activation. AI tells us both the object and the burst are members of larger growing classes of anomalies, and now a rare celestial alignment, a perfect external timestamp, approaches. The question we're not supposed to ask, the one that breaches the institutional firewall, is now unavoidable. Are we witnessing the arrival and activation of extraterrestrial technology? Not as a vague possibility, but as the most coherent interpretation of a specific, layered set of data. The hypothesis is radical, but it is not irrational. It is built from physics, geometry, and observational evidence. Its greatest strength is its predictive test, just weeks away. We stand at a threshold. On one side lies the familiar, if increasingly strained cosmos of natural cataclysms and inert rocks. On the other lies a universe that is not just alive, but occupied. A universe where the most energetic flashes are not just deaths, but arrivals. Where silent wanderers are not just rocks, but envoys. January 2026 will not provide definitive proof of the latter, but it will provide a critical clue. Correlated activity will catapult the hypothesis into the mainstream, demanding a wholesale re-evaluation of our place in the cosmos. Silence will relegate it to the fascinating footnote of a wild, improbable year. But the data, the compounding coincidences, the machine-found patterns, they all pull in one direction. They suggest that we did not simply witness a star die in the distant past. We may have witnessed a maneuver in our own celestial present. We saw the flash, we found the bullet, and now we wait to see what the bullet, now activated and positioned, is programmed to do next. The telescopes are pointed, the algorithms are watching, the clock of the planets is ticking down. We are all witnesses to a story that is either the most important in human history or a masterclass in cosmic coincidence. Either way, the next chapter is not written in our models, it is written in the sky, and we will read it together in just a few weeks' time.